조교들 좀 이어폰 같은 걸로 연결해서 내 오디오가 잘 주무르게 나가는지 테스트 좀 해주세요. I guess it is working now. Right. So, we usually divide the one class. One class is 90 minutes, but usually doing until 75 minutes. Divided into three parts. So each one it can be 25 minutes. I'll do my lecture about 20 minutes, and then one of you will have a lecture like me, another lecture of 20 minutes, and then there will be another discussion session. And that session is also led by one of you. So that is my operational mode of the class. And then grading and schedule, and then I will introduce myself and TAs. So course objectives. Did you get my email yesterday and last week? Raise your hand. Somebody who did not get my email. Nobody. So everybody get my email, right? Good. So it is already written there. I'm trying to introduce naval architecture and ocean engineering. It is actually as a two subject. Naval architecture and ocean engineering is different. I'm trying to combine and introduce to you. And who does not have a background on ocean engineering or shipbuilding. So that fundamental knowledge and also the basic terminology is important. And I guess there is one person coming from Samsung Heavy Industry. Is he there? Not today. We have a Samsung Heavy Industry branch office in Daejeon area. And one person is trying to attend this lesson. He sent me an email, but okay. So goal of this class is the basic terminology, once again, to non-naval architects or ocean engineers. So say I hope you can learn around this 1,000 terminology of naval architecture. You will learn that the terminology is very unique in shipbuilding and naval architecture, especially in naval architecture rather than ocean engineering. Because naval architecture, the history is very low. Several thousand years old. That's why they have a keeping old and unique terminology inside. And you will see in the future that those unique terminologies are used in another area or domain of engineering. Say, airplane or space. And also automotive also use some of that terminology too. And in Korea, the government tried to learn or let students learn about 2,000 Chinese characters. That is probably in my age of study. Probably now it changes. But that is a baseline. That's why I'm trying to say you can learn 1,000 terminologies. All right, course material, the lecture note, you don't need to buy a book if you, it's up to you, because the lecture material is available already in old website. Also will be updated this semester a little bit. So that's why you can see that. And the textbook is two. One is from book, how many years ago? 15 years ago? More than 15 years ago? 17 years ago? But title is good. Naval Architecture for Non-Naval Architects. Harry Benford is a professor in Michigan University in the United States, long time ago. And another book is Ocean Engineering. And SNAME is a Society of Naval Architecture and Marine Engineering of United States. The society, the academic society, they publish several books. So it's more old than the first book. Okay. And then the references, there is a Principles of Naval Architecture. We usually called PNA. That is also published by Society of the United States of Naval Architecture. And that is a 3-book volume. So that is very serious lecture or textbook for this area, especially naval architecture. Not much on ocean engineering. And then Korean title is a translation of this book into Korean English. So this is the book, first book by Harry Benford. This is original book, and this is a Korean translated version of same book. And this one is the second textbook on ocean engineering. And this is the serious textbook for naval architecture of principles with 3 volumes of. So I guess more than 90% of knowledge on shipbuilding or naval architecture will be covered, maybe covered by this. All right, grading will be, there will be only one written exam mid-term, and term project will be the same percentage as mid-term exam. And you will have I guess, everybody will have one lecture, I guess, I hope. And then also discussion session, leading one of you. And then there will be about 3 times of homework at the beginning of the semester. Class operation, once again, 75 minutes, divided into 3 parts. And first one will be given by myself. And second one will be done by one of you. And then another discussion session by one of you. Okay, we can see the video now. This is a website of last year. And there is a information notice, lecture note. So week 1 takes time. Yes. Not file, it's originally shown here. So all the material, similar one today, right? This was given. And then video. Okay, I guess this. TA, can you make this menu bar into English this time? This one is written in Korean, right?
I think that depends on the understanding. So if we want to say,
Oh, can you set my one here? All right, depending on my purpose.
설정을 바꾸면 될 것 같습니다.
Oh, good. Right. Yeah. So then, okay, depending on your settings. And this one shows better views. I found it yesterday. So this is not in historical list, but you can check the latest one, popular one, oldest one, or something. Well, I can show you that discussion session here. Sound is not coming. 이 사운드가 어떻게 해서 나올까요? 와서 좀 봐줄래? 여기 사운드가 좋네. 플러스만 사인이 없네. 아, 됐어요?
그게 주로 그 뭐였죠? 노트북 사운드 바꿔 사운드 아웃가 뭔지 노트북 사운드 아무래도 나오는 다시 보내.
Internet or earthquake. Building rigs and drilling for oil takes a lot of time, money, and power. Also, to avoid floating away,
He is speaking
it's either anchor
as a discussion leader. Usually, many students pick quiz time as a discussion session. You'll see.
Sure, building.
That screen is coming from the last year. Right. Stop. Right. So, and also I will provide you every time the Zoom link. So if you have any problem coming to classroom, you can connect on Zoom. And participation will not be counted by myself, but TA will be check the participation. Because I need to report to the department office about your participation. Zoom audio, you know better than me, but I usually link through the smartphone because smartphone provide me better sound than note. Student lecture, there will be another guideline, PowerPoint, how to do better. I'll show you next time. But anyway, the previous semester slide will be provided, say 1 week ago, before, usually by myself. And then you can study and then improve and explain to your friends. And I recommend to find out good video around your subject area and show to students that helps understanding the topic. Tom project, there are many because I operate this classroom many years already. So it's 12 years ago already. Mobile Harbor was at that time was a big project inside KAIST. And Seabase is coming from US Navy because US Navy may have a battlefield around Middle East at the time. They want to have a air base nearby, but it's not easy to find out good land base near around Middle East. That's why they trying to provide a floating air base. Anyway, and mobile harbor is for commercial transportation. Idea is coming from the air base, sea base, sea base, floating air base. This is about energy island. You can see that there are wind power system, also solar panels too, and also you can expect wave power generation with electricity, and also there are more. You will learn this from this class. The temperature difference, and also tide is different from wave. Tide is something like a stream below the ocean surface. Wave is usually on the surface. There are also underwater wave, with a special wave, but usually you can see wave on the surface. But stream is different. Nowadays, in Korea, we have some political problem with Fukushima nuclear power plant, and the water is coming from the Fukushima. And we learn about Kuroshio tide, Kuroshio water stream. Kuroshio is the name of a Japan scholar. He found that water flow around the Pacific Ocean. And so many Koreans are now heard about Kuroshio tidal flow. Anyway, you can use that kind of energy to produce electricity through using this idea of energy combined energy production. This is about Microsoft. Also, they try to put data center capsule inside the ocean because cooling is important. Cooling. And also land space is important. Expensive for them. This is idea coming from France. Who are coming from France? I know that there are many. Okay, good. They're trying to make a floating city or residential area. This is another view of this idea coming from the company. This is offshore port is similar to the mobile harbor. So you can see the container crane. This is a container crane. A big ship is here, and small ships is here because you need to offloading and unloading. And then this one is coming from yes, is Amsterdam or somewhere. For electric boat tourism. Also, the emission is important, and also the driver. I don't know whether this is an unmanned ship. And this one is coming from microplastic in the ocean. This is another garbage collection and project. LNG filled ship. Big ships. What can be done by yourself then this semester? Life-saving, unmanned ship, renewable energy, or pollution, you can choose. Spring last year, there was a project. There was only 3 teams. Subsea Hyperloop. That is for train between China and Korea under the seabed, and self-powered underwater data center, similar to Microsoft. And coral reef monitoring with animals. Ah, that was interesting. They tried to use a turtle to attach some monitoring device on above the turtle back and trying to use that device to monitoring the sea animals, their safety something. And then myself, you already know about this one, myself, and then there will be two TAs. Can you come over here? TA? Oh. Oh. You can introduce yourself.
Hello, my name is Min Che, one of the T in this class. Now I am PhD student in Beijing Zhang's lab. Hello.
What is
Nice to
your
meet you.
what is your topic of study?
My research topic is fuel gas supply system on fuel gas supply system with liquid hydrogen on liquid hydrogen propulsion ship. So now I'm making process design and analysis.
Oh, complicated. Fuel, hydrogen, fuel, and supply,
Fuel supply system
fuel supply system. From tank inside the ship or tank from land base or other way.
from the tank inside the ship
Inside
to
the ship.
fuel cell or hydrogen combustion engine.
Oh, okay. Oh. You can choose this topic as your term project. All right. Thank you very much.
Yeah.
There is another TA. He has a telephone conversation. SNS, I like to use SNS, especially Kakao. Kakao is a Korean brand. It's very popular inside Korea. So if you are trying to use while inside Korea, it will be helpful yourself. Anyway, I'm trying to make a Kakao talk of this classmate to make better communication. So you can talk with the TAs how to join that group, but it will be next week, not this week, because can be small changes on the website already shown to you, and then YouTube also there is a video of classroom. Because we are doing Zoom, the video is available every time. Any question? Any question? Student discussion. So what do you want to learn from this class? I want to know this. What do you want to learn from myself? Now or later, please let me know. And what is your curious item about ship or ocean? Questions? And lecture note or class operation? Any other items? Anybody? Nobody? Right. That's it. 30 minutes. So we can have a 5-minute break. 5-minute break. So I will back in 36. Right. Sounds good. 윤승환 씨 비디오 좀 켜보세요. 어디 갔나? 아, 윤승환이라고 줌으로 들어왔어. 네, 네. 말 좀 해보세요. 목소리 들려나 보게. 오디오 키시고.
아, 교수님 들리십니까?
말해보시라고.
어, 들리십니까?
안 들려. 소리가 안 나는데. 우리 아까 비디오는 소리가 나왔었는데. 뒤에 이들은 들려요? 윤승환 씨 목소리 들려요?
잠시만요. 혹시 들리십니까?
윤승환 씨 내 목소리는 들리는 모양인데, 윤승환 씨 목소리가 나한테 안 들린다고.
네, 교수님.
조교랑 체크 좀 하세요. 오디오. 될 때까지.
조교님, 혹시 들리십니까? 아, 아,
윤승환 씨 목소리 들어봅시다.
교수님 들리십니까?
아직도 안 들리는데.
잠시만요.
그쪽에서 안 들리나?
들리십니까?
작게 나오는데, 그럼 볼륨을 키워야지. 여기서는 안 나오는 것 같은데. 여기서 나와야지.
다시 한번 말씀해 주시나요?
들리십니까, 교수님? 들리십니까?
안 들려, 안 들려.
아,
저쪽에선 들려요?
네, 좋습니다.
들리십니까, 교수님?
이제 다음.
얘기해보세요.
예, 교수님. 저 잘
이제
들립니다. 네.
무슨, 뭐가 이렇게 복잡하지? 됐습니다.
네.
Any question? Oh. Okay. This is a sample tentative class schedule. So today I'm trying to introduce class operation introduction day. We'll see on Thursday again. So I will show you, probably I can do today also the overview of the ocean engineering. And also next week, I'll try to show you the overview of naval architecture. And then we can start with the ocean engineering textbook on next Thursday, starting. And then also we will do some introductory materials and also introduction, how to do your student lecture, how to turn project, and homework one is coming out. And then after 3 weeks and fourth week, we will start with your student lecture. Until then, I will do myself. Well, usually this format of myself, the first lecture, second lecture, and discussion every time. Okay, that is the operational way. Then, and the subject is here, and I will provide you the material of previous year. Okay. I did not update the old one yet, so that is the only thing. But this one, it can be overview of this way. Last year, we do on midterm exam during the classroom. And sometimes I have a travel outside of Daejeon so that we can do only Zoom classroom sometimes. And also sometimes we will do replacement classroom in evening of this slot, yellow one, evening. Sometimes, but because of the Zoom, I prefer to use Zoom rather than doing evening class. But depending on my schedule, and also I'll try to invite some specialists for guest lecturer. Professor Na was a Navy officer for a long time, or Korean Navy. So he will show you how Navy vessels are becoming or designing and production of warship. And also Professor Park have a long experience in Hyundai Heavy Industry, the industry shipbuilding company. And he was a specialist in structural strengths of ship. So he will have a special lecture. Last year he did, but I'll try to invite him again. And also last time we visit Research Institute, Korea Research Institute of Ship and Ocean Engineering, nearby. but we need to have a transportation. Anyway, it is about 15 minutes drive from here. So inside Daedok Science Town. Actually, I was employee at that Griso when I was young. So I have a friend there, already retired, but anyway. So last year we did a short one-day trip to, short trip to Greece. Also, as I told you that Samsung Heavy also has a research center nearby too. They also have a towing tank. Towing tank is a indoor swimming pool, but it's a 300-meter long. 300-meter long. It is for testing ship. Towing tank. Griso has I guess they have a 200-meter long towing tank, and also, but they also have a large scale ocean engineering testing tank. That is about, say, swimming pool, indoor swimming pool, but 40 or 15-meter long scale. Also, they also have a ice tank. Ice tank means trying to emulate the ice in Arctic Ocean, but small, minimized size, and trying to freeze the water there, and test whether ship is going well. And also another facility is cavitation propeller testing facility. So last time we visit those facilities. And then there will be 3 times of project presentation, 3 times proposal presentation, and midterm presentation, and final presentation. Okay. That is the schedule of this. I will try to distribute this class schedule also next week, end of next week. All right. Others. If you don't have a question, then I can start with the lecture material. Then ocean engineering. Okay. No question? So this is the book, the left one, the ocean engineering I'm trying to cover for the first part of this semester. So this slide set is around chapter 1, but after a long period of semester, the contents was modified much so that it is not coming together with the textbook nowadays. Many changes from textbook. Anyway, at the time, the green part is trying to cover by this semester. Ocean environment and offshore structure, coastal engineering, floating and body dynamics, underwater system, underwater acoustics, instrumentation, ocean engineering. Communication underwater is very not easy. You cannot use smartphone because the electromagnetic wave is not going through the water. Only available communication, not only, but major way of communication is acoustics. That's why we are using sonar. And submarine is very important for Navy because it's not easy to find out where is the submarine because acoustic is not good way of communication. but this is the only way you can do. So is it advantage and disadvantage? We'll see what is the acoustics of almost. Navy is very important. And nowadays, commercial road also depending on the acoustics for communication. All right, ocean, unexplored frontier on Earth. Earth's surface 70%, and water 97%. And then there are many unexplored. Recreation dive up to, usually when you go to a tourism, probably the coach do not allow you to dive into more than some, because of the health problems. Have you tried skateboarding? How many meters have you been to dive?
27.
27? Oh. Deep? What? Oh. And then technical dive and saturation dive. Saturation is the pressurized air tank. And average depths of the water, ocean or earth, and deep trench. Once again, trade. World's trade is carried by ocean-going ships. And more for Korea, because South Korea is something like an island now. No land-based transportation northbound. But this one is for weight, not price. So 90% is for weight. So you can expect that heavy cargo is transported by ship, crude oil, and or grain. Also cheaper and cheap and heavy cargos are transported. But expensive cargos, something like a smartphone, better be transported by airplane. Faster, but expensive. 97 water, and 2% of them are frozen water. Inland sea lakes are also, and 80% of life on Earth is ocean. Source of protein, fish production. Protein, you want to breed a cow, land-based animal, you need to provide them eating much grain. But in ocean, there are many available fish, so you don't need to provide them much of grain. So many people are saying only 1/6, say 1/6 is 18% something. So only 1/6 of amount of grain is enough to produce the same amount of protein in ocean. So it is cheaper, and also space is big. Volcanic activity and oil. 1/3 of the world's oil comes from offshore fields. Well, I guess it will increase in the future because land-based is now empty, getting empty, right? But ocean-based oil, gas is expensive than land-based oil. That's why there is a trade-off between. So oil prices going up, then there is more need for the oil coming from the ocean. Oil prices down, no, stopping, because it's expensive. Right. There's a nice video, so we can. Oh. It's coming from NASA. Those are Great Lakes of the United States, between Canada and United States. Gulf of Mexico, South America. I understand the NASA catch photos, and photos are combined into a video stream. That's why they made this. South Africa and Middle East. Middle East is India and over there. Ceylon. And then Malaysia, Australia. No, this is Indonesia. Philippines. So you see that Croatia flow is something like this one. Croatia. So it's moving upwards around this way. That's why the Fukushima water is not coming to the Korea direct. All right. So what is ocean engineering? There is a definition. So engineering principle, you apply engineering principle to the analysis, design, development, and management of systems that must function in water environments such as ocean, lakes, and estuaries and rivers. So related discipline, there's naval architecture. Naval architecture is we are trying to cover after later section of this semester. But it is easily can be saying as a shipbuilding. But Navy was the originator of shipbuilding because of the, say, more than 3,000 years ago. There was a battle. Egypt, Roma. So that the Navy want to have a good, big, strong, and fast ships. That's why they started to study how to build ship better. That's why the name coming from the naval architecture. Navy architecture, because Navy architecture. Marine engineering usually are saying about the engine of the ship. But you see that when the engine was developed first time, how many years ago? Engine? How many years ago the engine was developed? 1,000 years ago or 200? 250 rounds. Not 2,000, right? 200 or 150. Then you can say that before then the ship was propelled by row and wind, right? Wind. So Roman area, you cannot use the engine at it. That's why there was a historical differences. So marine engineering, the topic is started about 200 years ago. Right? But naval architecture is 2,000 years. But they may not use that terminology at the time, but the technology was starting. Coastal engineering, and offshore engineering. Offshore means the against the onshore engineering. Gulf of Mexico near south of Texas area of United States. There are many oil gas companies are there. Energy Isle or something, energy development. Because why? There are oil fields are much Texas, Gulf of Mexico. But in say 70 years ago, the oil producing from the land-based Texas area, many oil refinery there. But now they are almost empty, land-based one. So they are coming back toward the water area. That's why the Gulf of Mexico is more popular in oil producing. So you can see that onshore oil exploration was popular 70 years ago. And nowadays, no more in land-based. Sometimes they do. The remaining small amount is remaining. The technology is improving so that they can collect small remaining renewables. In 70 years ago, they don't want to use that small amount of refined oils and remaining there. But nowadays, anyway, so onshore was offshore. So nowadays, more technology and commercial companies are going into the ocean and Gulf of Mexico. That's why the wording is coming from. And fish farming is fishy. Aquaculture is another name of it. So naval architecture is for the ships, including submarine. Hull structure and propulsion. Propulsion is the engine. Hull structure is structure, the strength. Is it similar to this building? Trying to make this building floating on the water. Structure strength is coming from these pillars over there. So that ship is similar to having a main, say something like a pillar, like a beam. We call this a beam. Strong beams are, and then connecting the skins of the ship. We'll learn in the later stage. Anyway, structural strength is important, so that's why they say hull structure and propulsion system, the engine and propeller for marine vehicles such as surface and engine, say 200 years ago, they started to use engine in ship. Marine engine applies energy and mechanical systems used in marine vehicles. Okay. I guess this looks like a gas turbine, but big one. Looks like a gas turbine used for, or steam turbine, probably steam turbine or gas turbine. But anyway, turbine used for power plant, electrical power plant, I guess. But it can be used for the ships too. But this one, you can see the human here and here. You can expect the size of this one is the engine of the ship. The diesel engine, right? Very big, right? Inside the ship. The big engine is inside the ship. Slow speed diesel engine. But nowadays they are trying to change to what? Once again? Fuel cell? 문지호 TA 아까 인사를 못했는데 와서 잠깐 인사. 네. 네, 앞에 나왔어. Here is another TA. 네. Introduce yourself.
I'm TA's. My name is Ji Hoo-moon. this is my third year of teaching study and I study fluid mechanics. I'm not actually expert of this field, but I will do my best to make sure that there are no interruptions or revised before first. Thank you.
Oh, what is your study of subject?
It's fluid mechanics, and I mainly study CFD, computer fluid mechanics, so basically simulation. And with that simulation course, I study many topics such as bubble dynamics and magneto hydrodynamics and particle latent flows, something like that.
Have you heard about CFD before? Oh, okay, okay. About half of you knows what is CFD then. All right. So he is specialized in CFD. Then inside CFD, what you may have a subject of your PhD thesis.
Yeah, I'm currently studying magneto hydrodynamics.
Magnetohydrodynamics.
So it's basically conducting liquid.
Okay.
And the movement of magnetic field, it applies the Lorentz force inside its fluid element, so that it creates flow.
Okay.
So I'm studying. So
What can be the application of that study?
it actually can be used for the ocean engineering, such as like, for example, seawater is conducting fluid,
Seawater is conducting fluid. Right.
although the conductivity is relatively lower than other things such as like liquid metal, but still it's a conducting liquid, so it can be the magnetic hydrodynamic can be applied as a method of propulsion of the ship,
Propulsion of the ship. Okay.
like that.
Super conductive propulsion something, right? Yes, it is. All right. Thank you. All right. Marine engineering. Yeah. Okay. 10 more minutes. Any questions? Any question? Coastal engineering. Coastal engineering applies engineering principle again to systems operating in the coastal zone. So near the sea, seashore. This one, the left up picture, I guess this is Busan port. Busan is the second largest city of Korea, near southeast corner of the Korean Peninsula. Have you been to Busan before? Not international student yet. You may better to have a chance to visit Busan. And Busan is a main port of the South Korea. Right? And then old port was too old. Probably started used as a port when the Japan occupied Korea. Say 100 years ago. Right? Right. Now the old port is too old, so that they want to build a new port. This is a new port. I guess this one is an old photo that at the beginning of the development of this port. But now it is full operation already 10 more years. So very big and now main port of Korea. And this one is airport, but not floating. But they make land, pouring some sand and stones and trying to make probably this one is coming from Japan. The photo is coming from Japan. They want to make but also there is an idea to make a floating airport, as I showed you, the floating airbase or mobile harbor. They are saying you need to have a kilometer long takeoff, landing. So coastal engineering, this is about coastal zone around surrounding nearby between land and ocean. Offshore engineering, so onshore, coastal is onshore, right? Onshore, coastal, offshore is far away, right? Offshore engineering. Offshore zone with implies deeper water outside the coastal. But this one is very important for, especially for Korean shipbuilders, offshore engineering or ocean plants engineering to produce oils and gases, and also Energy Island too. But Energy Island is, I guess this is coming from graphics, not your fault. So still under development or idea generation. Because of the expensive construction and operation. Also, another problem is the long line of transportation of electricity. When you making energy is good far away because wind is good, wave is good, right? And no land costs. Right? But problem is when you get the electricity, you need the electricity transport to the land or city area. That is a problem. Anyway, that is it. And also scope of engineering, ocean engineering, we are trying to cover today. So naval architecture, some of them, marine engineering, the engine, some of them, but mainly about coastal engineering and offshore engineering. There is a coverage of the ocean engineering topic. Port and harbor, Long Beach. Do you know where is Long Beach? Nobody? One person? Two? All right. Can you answer the lady? Where is it? Say
On the East Coast.
no. No.
I only know the country, America.
America. United
Like,
States.
and maybe LA.
LA. Airport. Just below the Los Angeles. Main port. But anyway, there's many people don't know. This is a ship. This is a ship. Big ship. Big ship. So port is big. I guess you can see more ships here. Ships and ships and ships. And these are container cranes. Container cranes. They are taking out container from the ship and also loading and unloading containers. And backyard is a big container yard. You can store. The trucks are moving between ship and yard to store and moving, loading, unloading, and also land transporting. So in hotel, especially nowadays, container ship is important for cargo transportation. So that you need to have a big container yard and then container cranes. So you can see that there are many similar zones or container yard and container cranes and ship. So that they try to make more area side for the berthing. New container port looks like this. Long Beach is not largest port around the world. Yes, Shanghai port is the world's largest port. Amsterdam can be around 1/5 or because Amsterdam is the biggest one in Europe, EU. But cargo must be transported for EU and Asia and America and the big cities here. Right. Baltimore is also United States, East Coast. But it is not anymore looks like this one. Baltimore was a big port when US is opening or independence. When was the independence of the United States? 17 something? 1770. And it should be 250 something years ago, right? Those days, Baltimore was an important port center. Transportation mainly between Europe and United States. But nowadays, not anymore for big ships, but it's for tourists and residential area. It's a nice place to live there rather than commercial transport. They are changing the usage of the port area, all the port area. Okay, one more slide, I'll stop. Coastal structures. Jetties for a ship can touch to the structure. Big ships, problem of big ships trying to touch the port. So many problems. One is the depth of the water. Because the ship is big. How big is it? 400 meters. No. 400 meters means how many floors for building? This building is how many floors is this building? 6 floors? 5 floors? How tall is this building? 20, 30 meters. 20, 30 meters. When you are saying 300 meter long ship is standing in the land, then it can be 50 floors high, right? 50 floors. Then they should have a depth of water. Because probably that kind of ship, the depth of the ship can be say 50 meters, 50 meters. 400 long, the height is 50 meters. And then say half of them are submerged, then you need to have a 25 meter water depth. There is one problem for big ships coming into the port. Baltimore, they cannot accommodate such big ships. Another one is touching the structure because the ship is very heavy, 300,000 tons. They slowly touch them, can break medicine. So that the jetties for touching big ships, they should stay there for just unloading and unloading. You see, breakwater is for protecting the port area from the oncoming big waves. Storm is coming, and they need the protection. So the ships is inside the port. And Groy and Costa Guam is for the tourist sand areas. All right, that's it for today. Any questions? Otherwise, we'll see it on Thursday. Okay.